Good morning all, myself Dr.V.Hari Priya, working as Associate Professor in Chemistry, Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. So let us go with a problematic part. So let us go with one problem. Calculate high and low calorific values, that is HCV and LCV, of a supplied coal sample. Here solid fuel coal sample it is considered, and its data it is given. How much content of carbon it is equal to 80% they have given, and then content of hydrogen it is equal to 8%, and then nitrogen how much it is present, 2.5%, and then sulfur it is equal to 3.5%. Last but not the least, oxygen it is given how much, 4% it is given, and ash content it is also given like 2.2%. If you notice the chemical reaction of any fuel sample, this nitrogen it is considered to be non-combustible in nature. So this we are not going to consider for calculation part, and as it is ash content it is considered to be the residual matter. So it is of 2%. So nowhere it is concerned with this combustion reaction because it is a residual content. So this is also not going to be considered for the calculation part. So what is the formula? HCV is equal to 1 by 100 into 8080 into percentage of carbon. How much it is given? 80 plus 34,500 into percentage of hydrogen it is 8 minus 4, that is oxygen percentage, divided by 8 plus 2240 into what is the percentage of sulfur that is given in the problem? 3.5. So by substituting all these values in the formula of HCV, here I mentioned, substituting all these things and then doing the calculation part, that is simplification, we are able to get 9129.9 calories per grams of HCV. So given data it is substituted in the formula, and by simplifying all these values we got 9129.9 calories per grams as HCV answer. That is the result. So these are approximate values. So basing on this one, we are going to calculate LCV, that is equal to HCV minus 0.09 into percentage of H into 587. It is nothing but latent heat of condensation. Sometimes this 587 it is given or it is mentioned in the problem as a data. Sometimes they won't give. That means we have to keep it in mind. We have to substitute that latent heat of condensation. Okay. So by substituting all these things, we are able to get the result of LCV as 8707.26 calories per grams. So what result we got? 8707.26 calories per grams. So these are very simple problems. If you know the formula and the data, basing on the data that is mentioned in the problem, if you substitute all those things in the formula and then after simplifying, we will get the answer. So let us go with the one more topic, that is characteristics of a good fuel. Characteristics of a good fuel. So let us start with the first one, that is a good fuel should have or it should possess very high calorific value. So as I told you, fuel will contain two major components, one is carbon and the other one it is hydrogen. So it should be highly carbonaceous in nature, and second major component should be of hydrogen. If these two were present in more percentage, more amount, then only combustion reaction takes place in a proper manner in excess of air, and that fuel is able to release more amount of heat energy that can be captured and used for various kinds of applications. That's why if calorific value is more for a good fuel sample, then we will get more amount of heat energy. So this is the first criteria of fuel sample, good fuel sample. And the second one, it is moderate ignition temperature. So what do you mean by ignition temperature? Ignition temperature means starting fire process. Ignition temperature means starting fire process. So it should be always moderate in nature. That means it should not be very high or it should not be very low. So the starting fire process, if it is more, if it is very high, that means combustion reaction takes place with long flame, that means we become unable to capture that heat energy that was liberated. If it is too low, it is able to release smoke. Smoke is a pollutant during combustion reaction. If it is becoming incomplete, then it is able to produce smoke as one of the products. So it should not be very high or it should not be very low. So that's why we will call it as moderate ignition temperature. Starting fire process should be always moderate in nature. And coming to the third most important property or characteristic of a good fuel is it should contain low moisture content. Moisture content is nothing but H2O in the form of vapor, water vapor, it will be present. So it should be always low. If it is more, then it is able to absorb some amount of heat energy. That's why if moisture content, if it is present, then it is able to absorb the heat energy. That means the fuel will have, or the fuel will possess less calorific value. So moisture content presence is able to affect the calorific value of the fuel. So that's why it should be low. If the moisture content, if it is low, then we can say that is the good fuel. So that is most important property of a good fuel. So always it should be low. If moisture content, if it is low, then that fuel will possess very less calorific value. Fourth criteria, it is low non-combustible matter. Coming to non-combustible matter, that is nitrogen. So nitrogen, it is nowhere responsible for combustion reaction. So if it is absent, then we can call that fuel as a good fuel. If it is present, then it is not having any kind of role to play in combustion reaction. So that's why it comes under non-combustible matter. If it is low, then we will call that fuel as a better qualified one. So that is the fourth criteria. And coming to the next one, that is medium velocity of the combustion reaction. That means the speed with which the combustion reaction it is taking place. As I told you in the point 2, it should not be very high or it should not be very low. Ignition temperature we discussed. Same thing with speed of combustion reaction also. If it is very high, that speed of the combustion reaction, if it is very high, then that combustion reaction takes place within no time with long flame. We are unable to capture that heat energy. And if the combustion reaction speed, it is very low, if it is happening with slow rate, then smoke will be obtained as one of the products. So it is a pollutant. So always the speed of the combustion reaction should be medium. So that is the most important criteria or characteristics of a good fuel. So coming to the next point, that is products of combustion reaction should not be harmful. So CO2 that is released, we know very well. So it should be in permissible limits. So easily it can be released into the atmosphere. So and then H2O it is produced, along with that heat energy will be produced. So like sulfur, if it is present as one of the components of fuel, so it is highly toxic in nature. So it is able to release its oxide form as products. Oxides of sulfur sometime will be produced as products if it is present. So these are harmful to the nature, these are not eco-friendly. So products of combustion reaction should not be harmful. That means it should be free from sulfur like toxic chemicals. At least in permissible limits they should be. So and the next thing, it is combustion should be controllable. Combustion reaction should be controllable. That means the rate of combustion reaction should be controllable. Or whenever you want to proceed in faster manner, you can. So like that, one should have a control on combustion reaction. So this is also one of the important criteria for a good fuel. And then coming to the last important criteria, that means it should be available in cheaper cost, and it should be easy to transport. Wherever you want, you can transport. It should be easy to transport, and it is not able to release the smoke as one of the products. So smoke is a pollutant, so it should not be released. So these are 8 important criteria or 8 important characteristics of a good fuel. It should have high calorific value, or it should possess high calorific value. If it is having high calorific value, then only we will get a lot of heat energy after combustion reaction, and it should possess moderate ignition temperature. That means starting fire process should be always moderate in nature, and then low moisture content. If moisture content is high, then it is able to reduce the calorific value of fuel sample. That's why it should be always low in nature. And then low non-combustible matter. Example, I explained you about nitrogen content, it should be low, and then the speed with which the combustion reaction it is going to take place, it should be always medium in nature, and the products of combustion reaction should not be harmful. That means those are to be eco-friendly towards nature when they were released. That's why we can say it is should not be harmful. So example, we discussed about sulfur and its oxide form, and then combustion reaction should be controllable. That means at any time if you want to control the rate of combustion reaction, it should be controllable. So and then it should be available at low cost, easy to transport, and no smoke it should be produced or released during the combustion reaction. We came to end of the session. So far what we have discussed in this today's session. First one, it is we discussed about units of heat or calorific value. 4 different units we are going to make use of expressing the calorific value of a fuel sample. 4 we have discussed their definitions and their interconversion also we discussed in today's session. And secondly, we discussed about the determination of calorific value of a fuel sample, supplied fuel sample, by using Dulong's formula. Dulong's formula. So using Dulong's formula for HCV and LCV, 2 different formula are there. Using that formula, we discussed about how to determine the calorific value of a supplied fuel sample. So next, we did one problem using this Dulong's formula for finding out the HCV and LCV values of a supplied fuel sample. Lastly, we discussed about characteristics of a good fuel. Characteristics of a good fuel. So that's all for today's session. In the next session, we will go with liquid fuels. Crude oil is the best example, how it can be extracted, and then how it can be subjected to refining, that is purification, and how we are able to get different fractions from that crude oil. That's all for today's session. Thank you so much.